Okay, this is chapter 2, section 8. This will be a shorter video because it's taking a lot of the same concept that we learned last section. It's just now applying it to shapes. Okay, so we're going to be dealing with proportions and similar figures. Okay, the objectives here is find the missing lengths in similar figures, which we'll explain what they are in a second, and then to use similar figures when measuring indirectly. All right, so from this slide, what we want you to do is make sure that you have this written down. And what that is it says similar figures have the same shape, but not necessarily the same size. Okay, so down here is a perfect example of this. We have two triangles. Now it's important to understand that when we say same shape, it's not just one triangle and another triangle. It's not like a triangle that looks like this. That was horrible. It's not a triangle that looks like this, and then another triangle that looks like this. Two completely different triangles. It is triangles that have the same basic shape, so they're the same type of triangle, and the big thing is they don't have the same size, but they're proportional. All right, so you also want to write down this. Now I know many of you, or none of you, have taken geometry yet, but this represents the triangle. So the way this is set is triangle ABC, that's how we name it. So this triangle ABC is similar to triangle FGH. And some little things that you need to know is the way in which we name them is very important. You notice how we went A, B, C, and the same order F, and then we went down to G and then H. That's very important, okay? And the reason is because those sides are supposed to go together. So you see these first two letters, AB. If we take that's side AB. If we look at the first two letters over here, FG, it's the same side. And the reason that's important, because what if we rotated one of these triangles, right? What if we took this triangle and we maybe flipped it a little bit, or we rotated? Okay, those may be similar triangles, just rotated 180 degrees. Okay, and so you would have to notice that this side right here goes with this side over here. This side at the bottom goes with the side now at the top, and this side, which is called the hypotenuse, which you'll learn later on, it goes with this side right here. Okay, so those are just some things to keep in mind. And basically what similar means is they have the same proportion. All right, so we're going to look at this down here. And I want you to write all of this down as well. Pause the video if you need to do that. What this says is that in similar triangles, all the corresponding angles are congruent to each other. So angle A and angle F are congruent. Congruent means the same measure. B and G are congruent, C and H are congruent. However, the ratios of the sides are equal. Not necessarily the lengths of each side, it's the ratio. And so what we're talking about here is if we take this side, AB, compare it to FG, that ratio, which is 8/12, is going to be the same as AC, which is 10, over FH, which is 15, which is equal to BC, which is 12, over GH, which is 18. And what I mean by that is, if we reduce these, 8/12, 4 goes into both 8 and 12. 4 goes into 8 2 times and into 12 3 times. 10/15, 5 goes into 10 2 times, and 5 goes into 15 3 times. 12 over 18. 6 goes into 12 2 times, and into 18 3 times. So you notice their ratio is all the same. That's what similar means. Okay? So what we're looking for is find the length of a side. Okay, so we have these two triangles. Right here they tell us that they are similar. So they want us to find what is that right there, DE. So what we need to do is we need to write a ratio of two sides that we know. And those two sides are BC goes with EF, right? BC and EF go together. So I'm going to write BC over EF is 16 over 12. And that should be the same as BA over, BA right there, over ED. So I know I know BA is 10. I don't know ED. So I'm going to put X there. And now, if we get rid of this, which you didn't necessarily have in the need to have in the first place, now what we have is a simple proportion that we can solve. So 16 times X is 16X. 12 times 10 is 120. And if we solve that, we divide by 16. And 120 divided by 16 should turn out to be, I gotta do some quick math right here. $7.5. Okay. So we're looking at A right there. Whoa, 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 stop, stop, stop. All right. Next slide. So we can use these proportions, what they're calling indirect measurement problems, okay? So what we're looking at here is the way that the sun strikes a building and a girl at the same angle. And what we've done is we've formed two similar triangles. So here's a triangle and here's another triangle, and they're similar. So we're looking for, we know that the distance from here to the girl's feet is 3 feet, and from here to the building's bottom is 15 feet. We know that the girl is 5 feet tall. We're wondering how tall is the building. So we're going to write a proportion. So we have 3 compared to 15. So if you remember the wording from last section, 3 is to 15 as 5 is to x. Cross multiply, we get 3x equals 75 divided by 3. And therefore the building is 25 feet tall. Okay. A man who is 6 feet tall is standing next to a flagpole. The shadow of the man is 3.5 feet, and the shadow of the flagpole is 17.5 feet. So here is the triangle, here's the guy, here's the man. Okay, and he is 6 feet tall, and his shadow is 3.5 feet. And then you have this building where the shadow is 17.5 feet, and we're wondering how tall is it. So again, we're going to go 3.5 over 17.5 equals 6 over x. And if we cross multiply it, we we get 3.5x equals 17.5 times 6, 0, 3, 4, 2, 5, 105. And divide by 3.5. And we should get x equals 30. All right. Last one. You can also use this for scale drawings. Okay. So a scale is just the ratio that it's drawn in. So we're going to look at the actual distance from Jacksonville to Orlando. All right. Now, what we need to know is this little scale down here. So our scale is 1 inch is 110 miles. So we're wondering in our on our map how far in actual miles, which we don't know, is Jacksonville to Orlando. Well, how many inches is that? So that's 1 full inch and another 1/4 of an inch we're looking at. This is a 1/4. See, there's 1, there's a half, so that's a 1/4, that's a half, that's 3/4, that's a full inch, there's another 1/4, so that's 1.25 inches. And so now if we multiply across, 1 times x is x, and 110 times 1.25 is going to give us 137.5 miles. Okay. Those are the type of things that you will be doing on tomorrow's assignment. I know this was quick. I know it was some concepts that maybe you're comfortable with already and others you may not be. Take some time, go back, look through it again. If there's something that you don't quite understand, make sure that you ask questions tomorrow.